I'd be hard-pressed to do anything quick in this train wreck. What have you been eating concrete?
I'd like to shower longer, but there are things to do.
You already have it, old goat.
You alright? Who are you?
It's a
And all this time I've been smoking harmless tobacco.
Well, as a computer man, I'd have to say the horse racing computer, but I'm interested to see the sex machine in operation.
and you.
Okay, I think we're ready. This is more last minute than usual. Hello. That's good. Yeah, alright. Wait a second. I was wondering why my armrest wouldn't go under my desk, and the answer was my chair was kind of not upright, which is bad. Okay. Let's cut out of here. Hey, hello. How's it going? Welcome to another another porting stream where I port a game, a Macintosh game in fact, from 1986 to God's Own C++. The game is The Fool's Errand by Cliff Johnson, and I keep saying this, but we're quite close to the end. Most of the puzzles have been added to the game engine. In fact, you can look at this after a bunch of... oh my god, I had to like go through some of these puzzles. I'm not going to say which. I'll give you a hint. It's the one that causes epilepsy. I had to go through them like quite a lot of times to kind of figure out what was going on with the progress tracking, because like for instance Wheel of Fortune, because I made a frigging typo in Wheel of Fortune, whenever you completed the card game it wouldn't give you it wouldn't mark that as being progressed. So it would be the same as if you just kind of quit. So that was kind of disheartening. It took me like maybe 3 or 4 playthroughs of the Wheel of Fortune with a win before I realized, oh crap, it's not working properly. Or rather, like, how to fix the thing that was busted. But you can see here, I've unlocked pretty much most of the story. Ignore the checkbox that's still next to Hermit and Justice. I fixed that, just not in this save game. That should be harmless from my reading of it. But the only real puzzles that are still left on the grid are the Archway and the Maze of Hedges. And those are both maze type puzzles, which relies on module 136, which is... I know I kind of said the High Priestess was the most complicated module in the game. Oh no, maybe I said the Word Jump was the most complicated module in the game. This isn't complicated, but it's long. It's, how many bytes? 3C78. So there's a lot of... Which I guess makes sense, because like there's obviously a bunch of drawing code to convert the maze from a textual form into a graphical form, but there's also like a lot of tricks and traps and stuff in the maze which have to be which are kind of just their code, essentially. It's all code. So how far have I got in the transcription? I think I got about halfway through the transcription before we started the stream. Yeah, so we've done from about 0 to 80, and then I've done from 274 to 300 or 3870, which goes to the end. So we've still got about 2,000 odd bytes, or hex 2,000 odd bytes left there. So that's one thing. The other thing which I wanted to look into was this game actually has sound effects. Most people, I think, who would have played the Macintosh edition that came from Cliff Johnson provided on his website will not have heard these, because they were removed for the 1998 re-release of this game. Possibly because they rely on the old pre-sound... I don't know, there's like Sound Manager, which I think is the new one, and Sound Driver, which is the old original Macintosh API that it relies on. Anyway, it is a very basic kind of audio playback mechanism. Really, it is... In fact, it's quite similar to the... it's quite similar to... I was going to say the PC speaker, but really it's more the Tandy 3 voice. So you've got, I believe, 4 square wave voices, and you can specify a frequency and a volume, and then you can chain them together to kind of make kind of amplitude modulation effects. So it's not as, and that's all done in software. It's not done. It's not a hardware chip like the Tandy 3 voice that relied on like I want to say like the Texas Instruments SN75 something, like the programmable sound generator from the Master System. Anyway, they don't have a chip like that, or the AY3912 I think is the other generic part name for the PSG. But anyway, this is all done in, so this is one of 3 modes I think the original Macintosh gives you for playing back sound effects. So let's cut over to, I might start off with that because I've had my fill of just boring transcription, and I don't want to kind of spoil too much about the end game for people who haven't played Fool's Errand yet. So I'm probably not going to show too much of that off on stream. But we can talk about sound API, start sound. That's the one. So here we go. Okay, sound driver. Yeah, so there are three modes. There's the 4-tone synthesizer, there is the square wave synthesizer, and then there is the freeform synthesizer. As far as where ZBasic only relies on the square wave synthesizer, which only uses about 2% of the processor's time. I think the 4-tone synthesizer is basically the same as the square wave synthesizer, except it uses sine waves. Yeah, so we've got like sine wave, square wave, and freeform wave, which is basically PCM. I don't understand why the freeform wave would be cheaper on the CPU than the sine wave driver. Like, oh, possibly because 4-tone synthesizer, like 50% is like, if you're playing all 4 tones at the same time. Yeah, so what I was thinking of doing is that there is some useful code inside ScumVM already, or rather like it was designed as a sound driver, like the PC speaker driver does in fact have a bunch of other tone oscillators in there as well. I'm wondering, I was thinking of just using the PC speaker driver straight up, but given that we need to be able to support like amplitude modulation, I figure that maybe we should just fork it and have a go at writing our own sound driver. So yeah, okay. Synthesizers. I guess the trick with the the square wave synthesizer is that there is no there's only one channel, because like the 4-tone synthesizer, oh no, okay, so the 4-tone synthesizer is used to produce harmonic sounds such as music. It can simultaneously generate 4 different sounds, each with its own frequency, phase, and waveform. Interesting. Okay, so you can potentially, how do you define the waveform? So yeah, start sound basically just kind of takes a buffer and then goes to town on it. Which, yeah. Sound driver hardware. Asynchronous device manager, right call. Okay, so don't worry, we're not going to worry about the freeform synthesizer just yet. We've got the square wave synthesizer, which takes just these tone records, which is just frequency, amplitude, duration. Okay, and then we have like the 4-tone synthesizer, which has oh, interesting. Okay, so it's got like a rate, a phase, a duration, and a wave. That is interesting. I do then kind of wonder how. So it's not quite MIDI, because like for each record you have to specify all of these different rates and phases. Anyway. I'm interested to know like what kind of waveforms they got. So they've got, yeah, 4 tones of such starting by the waveform description specified by the phase. Yeah, okay. Where's the? Not gonna tell me what the list of waveforms are. A digital representation of a waveform is simply a sequence of wave magnitudes. The bytes are stored in a data structure called a waveform description. Since a sequence of bytes can only represent a group of numbers whose maximum values differ by less than 256, the magnitudes of waveforms must be constrained to these same limits. Okay. Tell me more about waveform descriptions. Where are they? Okay. Oh, I see. Right. So the freeform synthesizer, you can describe what waveform it is. The type free wave is declared with 30,001 elements. So that's kind of the upper limit of your, I guess, sample size. Freeform synthesizer, square wave synthesizer. The waveform description specified by the phase, as shown in figure 4. I mean, like, yeah, the freeform synthesizer makes sense because that lets you specify what wave it is. I was just wondering, like, here in, like, the 4-channel or the 4-tone mode. Okay, we have, like, wave... Oh, I see. Okay, I missed this part. So, wave pointer is a packed array that is 255 bytes long, I suppose. Each rate value determines the speed which the synthesizer cycles through the waveform from 0 to 255. Okay. Well, we don't, you know, that's going to be overkill for what we need. We just need to get a square wave. So, I thought I did like a little bit more work on this. Oh, maybe on my computer in the other room. It doesn't matter. We'll just start again. We didn't get very far. Or if we got far, then it's probably not too bad. Okay, so synth. Okay, so we've got in our fake square wave synth structure here, which sets out count, amplitude, duration. Hey Kinnikos. Kinnikos says, I just went for a massive ordeal to get PCM to build from the latest Git, and now I have to painstakingly set up MS-DOS 6.22 all over again. And I don't have auto-exec bat and config sys from years back when I had to set it up under VirtualBox. Yeah, you have my sympathies setting up DOS afresh can be just a massive ordeal at times. But I don't know, how did I last do it? I think that, yeah, when I needed to set up on MAME, I found a boot disk, and then I found a floppy edition of the MS-DOS installer, and then that mostly handled the misery for me. But obviously it doesn't give you all the devices and stuff that you kind of need. All right. Okay, so we've got this record. We... Oh yeah, Kinnick says, I like how MS-DOS 6.22 supports the year 2026. What is the cutoff for DOS with the year? I remember it's lower than... It's low. I thought it was lower than 1970 for some reason. All right. So at this point, I think it would behoove us to look at how the rest of ScumVM deals with this. Audio, try it. Sorry, soft synth PC speaker.cpp. Okay, so if we open up the PC speaker driver, yeah, so it's got this kind of, I believe this is, the PC Junior, I think, is possibly why we have like square, sine, saw, triangle, and silence, but like the stock PC speaker doesn't really generate. It only generates square waves because it's just like a binary on and off timer. But more importantly, that this driver kind of sets up an audio stream, which is the C++ kind of... Actually, no, sorry, we've got PC speakers, which is, I guess, the device. And then we've got PC speaker stream, which is of type audio stream. Audio stream is the base ScumVM type that's used for any kind of audio source, essentially. So that could be like a file that is generating the audio. It could be a process which is generating audio, like a soft synth. But yeah, it then goes straight into the mixer. Yeah, that's right, Kinnikos. We're trying to add in the square wave mode of the original Macintosh sound driver, because that's basically all we need to get for Fool's Errand. And to do that, we are going to borrow from how the PC speaker driver has done it. In particular, like we've got this function here to generate, not a saw. Yeah, so like the square wave generator is pretty much just returning one extremer or another, depending on where it is in, I guess, an oscillation period. So like for something like this, we have, I mean, like this takes in a series of triplets which define, you know, how long to play a sound for and like what volume to play it back at. So my thinking is that like the nicest way of going about this would be to have an audio stream type which gets auto cleaned up, and then based on that triplet information, it just goes through and plays each one. And then when it runs out, it just kind of stops, or it just kind of self erases, which you can do with the audio streams. The audio streams have a time to live, or a kind of a lifetime parameter called dispose after use. And if you set that, that basically means that when you hand over a pointer to an audio stream, then that becomes acquisition for the mixer, and the mixer destroys it, which causes problems if you're in, I don't know. There's like a whole bunch of stuff in the director engine which requires specific lifetimes for that, so you have to be careful. Not so much here. We do not have to be careful. Okay, so if we were just going to do a very basic square wave generator, like what yeah, so this one is kind of complex because this audio stream, I believe, is designed to act as like a permanent, like you're not meant to spawn them every time the PC speaker does something. It's just a stream which is constantly outputting the audio that you want. So I mean, we could just do that model. We could just have it as that, but really, yeah. So like kind of where things get complicated, right, is that normally the boundary of the PC speaker is fine because you only ever have one input into the PC speaker. Whereas if we're thinking of this in terms of like the Macintosh audio system, you can technically have multiple things entering in, and there is a certain point at which there's no point reinventing the wheel and writing our own mixer code when there's already a mixer. Race of the Beam says, is this the high level approach because it's going via ZBasic, so there's a high level of abstraction to build against? Sort of. So if we look at like the ZBasic API, it is as dumb as rocks. It's literally you just take in a frequency, a duration, a volume, and a voice channel. I'm unfamiliar with what the purpose of this final argument is meant to do, because from my understanding that this just uses the tone generator in, well, this uses the Macintosh Toolbox API to call start sound, and then start sound in turn uses the tone, the square wave generator, sorry, rather than the 4-tone sound. So I don't quite, hang on, where's the ZBasic manual? This is because I'm also sure that voice is like a Macintosh special, like it only shows up on the Macintosh version. Yeah, okay, so like the sound statement. Maybe used to create sound effects or music. And then here it says, see appendix for using 4-voice sound and utilizing the sound buffer. So they've extended this command for Macintosh, so potentially you could do more complicated audio. Like, interesting. Okay, so there's like another kind of, there's a wave statement, which I didn't clock existed. Set the waveform of the sound output used with the sound statement. So you can specifies one of the Macintosh voices, 0 to 3, default is 0. Sine specifies a sine wave, this is default, and variant sets the wave format in an integer variable array. There must be at least 256 elements in the array. Interesting. Okay, so my guess then is that this isn't actually using the square wave generator mode. It is using the 4-tone generator mode with a Actually, I don't know. When I listen to the audio coming out of when I listened to the audio coming out of MAME, it sounded like a square wave. Like, it did not sound like a sine wave at all. I don't know if that's because, like, the default is for the... Because, yeah, like, we've got talk, sound. Okay, so... Same as Z-Basic sound statement with the following enhancements. Sets the volume output, values from 0 to 3 signifying which voice to use. The Macintosh is 4 voice. Also see the sound function and wave in this appendix and sound in the main reference section of this manual. Yeah, Madmo says, I've also been working on audio for that last couple of days. You can set a custom waveform. That seems neat. Yeah, I mean, the Macintosh audio playback API does sound kind of, you know, for 1984 standards, it's pretty freaking advanced. Like, it sounds like they were just really limited to being like a software synth. They were just limited to like how much the CPU or whatever could throw out. But yeah, you can set the wave data. But hang on, like, okay, there's an easy way that we can just kind of verify what's going on. And that is, we're going to start up MAME. And we're also going to start up this audio recording software. We want to record from... Yeah, I think this will work. So, start taping. We'll go to Justice, which has like a lot of audio. There we go. And yeah, it's just a square wave. Nothing nothing sine wave about this. So given that in the alright, I say given in the code, but it could be I mean, let's look up a couple of places where sound is called. Like, I think sound is called a few times in the maze, so we could probably just look at that that disassembly, assuming that I've got it here somewhere. Alright, that's good enough. You can go. Here we go. Oh wait, that's right. There's only one. There's one wrapper function which calls sound. 50E. Okay. For some reason, I've still got it labeled as ZBasic Unc 6 in my my disassembler. Oh, okay, and then we've got Unc 5. Unc 5, I'm pretty sure, is the command which checks to see if the sound is playing. Mamo says, I got June SB AdLib music driver reverse engineered and hooked it up to Nuked OPL3 and it just worked. Oh, nice. Was that multi-channel? Oh no, the audio was not multi-channel. It was just a single... Like, the code is basically play a square wave for a certain amount of time and then go to the next thing. So I just kind of assumed that it was covered by that. I think in the interests of kind of just keeping things simple, and because we're not really targeting every ZBasic application, I'll just put in a note saying, fix me use voice and to program the four-tone anyway. Oh, Kinigo says, what makes that iconic Macintosh startup sound? That sounds like PCM. Yeah, I mean, like, later on ones, I believe, were definitely PCM, but the... You know what? Actually, I'm not sure. I'm not sure about, like, the one that everyone... The one that you're thinking of, like, which is definitely kind of like a synthesized chord. Like, I'm not sure if that might be done with the wavetable synth. Anyway. Okay, so I think probably the easiest way to meet the letter of what we need to do is we just create one mixer channel, and then start sound, yeah, and then we just get start sound to either play, and I think there's a deal with start sound where if like you put like -1 in this pointer, then it blocks, but otherwise it does not block. And then we just have, because there's only one channel, we can just implement unc5, which is like the waiting for command. So like if we go up to the sound statement, yeah, okay, so like we've got sound wait and we've got sound resume. I swear there was like another command which just was like if the sound is busy. Nope, don't want that. Oh my god. Sound function. This is it. Okay, sound. So if you just call sound by itself with nothing, then that returns the number of sounds in the sound buffer. And effectively that's like whether or not the sound command is doing anything, I think. So that's my understanding of what unc5 is. So we go unc5. Oh, okay, and then so really it kind of buffers them as well. This isn't something we really need to simulate, but it is useful nevertheless. So really it's not checking whether or not the sound card is doing something necessarily, although it kind of is. I don't know. We'll leave it as Unc 5 for now. Yeah, okay. So maybe the easiest way to scab around this would be to have an audio stream class which doesn't play forever. It just takes in whatever the synth data was and queues it up and then auto destroys when it's done. So if we look at how this is done, yeah, like for real, this is pretty much. I mean, okay, so not gonna lie, this is essentially what we want, except with amplitude in there as well. Okay. I don't know. Like, it's like, this is the point. Like, I am hesitant because I'm like going, this is so similar to what we want. Is it worth just, given that the PC speaker driver currently has the ability to have different types of waveforms, which is not, as far as I'm aware, it's not really used by anything. Should we not just add amplitude to the commands? Like, for real though, where is this used? There's like the PC speaker music plugin. There is this PC Junior music plugin. There's this like play queue. Okay, so we have like AGI, which kind of uses this. Which uses this. And mostly, yeah, just the square wave type. You know what? All right, let's see if we can just add a little modification, just a little one. It's got to be obviously like compatible or call compatible with what we had before, but yeah, like when we look at, I guess, these outputs. Yeah, okay, so it just generates a wave. Okay, and then it multiplies by this volume, this freaking volume parameter, which defaults to 20, and you can't override it. So I mean, like, the easy way to kind of sort this out would be to remove this parameter and then just make it a default in each of the commands. So if we go like, yeah, okay, I don't think anything uses the volume parameter. But then if we look at like this command format, okay, and then we got rid of this. Oh, okay, then we got like OSC samples and OSC length, which is, oh, okay, so we do need volume here. Okay, great. That's good. Mamu says, sounds like a volume value that was derived rectally. Probably just from I'm guessing that was just the value, the 8-bit value, which just happened to be within the range of human hearing that doesn't cause you to bleed out. Sometimes, yeah. I mean, yeah, to be fair, like PC, PC speaker just played everything at maximum volume because that was just how it rolled. And if you wanted to control the volume, you had to buy a bigger speaker cone, which was harder to drive. So it's kind of luxury that we have the opportunity to change that. But anyway, okay, so in that case, we don't need to do that. Okay. Oh wait, no, but then we've got, so that's fine, but then we run into like the other downside of using this, which is that it then becomes harder to establish if it's doing anything. Because we're no longer using, we can no longer like poll the mixer to say whether or not the sample's finished, because it'll never be finished. Okay, that's fine. We'll just... Where is the constructor for the toolbox? It's in here, I think. It's at the top. Beneath this? Yeah, it is. Okay. All right. Let's go. All right. So what do we do in Director? We just have a sound channel structure. Which I'm pretty sure is in here. Sound channel. Okay, which then has a handle. The handle is used for interfacing with the mixer. Okay, so you don't have to actually... By constructing the sound handle, you've effectively got it working. Okay, well that's not too bad. We can work around that. Because like with this here, we've got our queue of instructions. We've got these methods which always say that there's stuff playing, so just never ending stream no matter what you do. Okay, cue the specified playback instruction. It'll be executed when all previously queued instructions are finished. Use this method for playback of effects which require timing precision of less than a millisecond. Calling this method will terminate any waveform started with the play method. Calling the play method will terminate the active queued instruction and clear the instruction queue. Use is playing to check if all queued instructions have finished playing. This will return true even if the current instruction is playing silence. Okay. Now, say that I wanted to look at the Macintosh API again. Was it sound begin? Hey, start sound. It's like this is the sound API. It's 4 functions. It is start sound, stop sound, sound done, get sound vol and set sound vol. So tell me about sound done. Sound done returns true if the sound driver isn't currently producing sound and there are no asynchronous start sound calls pending. Otherwise, it returns false. Okay. Yeah, and then we've got volume, which is a value from 0 to 7, as distinct from... I mean, the square wave, you can give like a 16-bit number to suggest volume, which I found odd, but I'm guessing it doesn't actually resolve. And similar to how kind of like color quick draw deals with like 16-bit color channels, I don't think it actually uses all of them. I think it just cuts it down to 8, if that. Yeah, right. So let's just prototype this. So bool toolbox sound done. Also, oh, hang on. I think I think what I'll do is I will close the text editor and open it again, because it's kind of collapsing, I think, once you open too many pages. Okay, so we've got sound done. I guess there's get sound vol and set sound vol. Oh, and stop sound. Okay. These aren't really used anywhere, but we may as well just add stubs for these. Oops, I got it around the wrong way. That'll be set. All right. Okay, so here's currently all the shared state that we're keeping track of in the toolbox object. I guess we will add... Is it an audio handle? I guess it's an audio handle. Oh no, sound handle, isn't it? Yeah, audio sound handle. Where is that defined? Would that be audio mixer.h? Yeah, okay. And then in the constructor, we'll go as PC speaker stream. Yeah, oh right, okay, so we're gonna have to, that would actually be a pointer, wouldn't it? In order to play back over the mixer, I think. Okay, how did the AGI engine do it? Okay, so the right, okay, so we'll just use the PC speaker object whole hog. Oh yeah, I'm gonna have to modify all these. It's like getting a little silly. So we'll say come on, Vim. You know what I mean. Okay, and then okay, that should be everything. Oh, wait. Yeah, and this suddenly becomes volume. Yeah, okay. I think that should be fine. Oh crap. It just occurred to me because I kind of have, because I don't know, might have to hit maze with a hammer a few times in order to get this to build properly, but yeah, okay. Yeah, that's to be expected because I didn't include that. We can fix that. Okay, yep. I'll have to fix a couple of things. Where did I put? Looks like most of the whinging is because of that. Okay, just a couple left. Okay, well that... Missing initialize for region data. Fine. Oh right, because I didn't add those. Didn't add those functions to. good. What am I gonna say? Okay, and then back here in the constructor, yes, synth equals new. Okay, I'm gonna do that up here. So we go. And then we just, how do we? I mean, okay, blah. If we're doing it the way the AGI one is, we could have this like high level PC speaker abstraction, which I guess manages the relationship with the mixer for you. Yeah, okay, so like this is kind of like wraps it up in a neat bow and sets up this stream. I don't think we need this wrapper class. I think we can just use it directly. We'll just, yeah. We'll just sort this out in here. Actually, yeah, we should use the output right. So we've got a channel that we allocated for ourselves. That was sound driver. Then on exit, that's what speaker handle was. Okay. So we've got our fake PC speaker audio. So now we can just make a call of that. CW synth. Oh, sorry, it's just rec. Triplets. And then it would be right, and then okay, what was the conversion? The conversion for those, for the square wave synth. So we got like count, amplitude from 0 to 255, and then duration in ticks. Okay, the count integer can range from 0 to 65535. The actual frequency is this figure here. Okay, great. So 783360. 783360 divided by okay, then length in microseconds, and which is now duration in ticks. So that's now going to be okay, length in microseconds for just a plate. So microseconds would be millionths of a second, I think. Divided by 60 times min amplitude 255. Okay, count values. Okay, and then that queues it. Oh wait, but there we go. So we've got the duration integer indicates the number of ticks the sound will have generated. Each phase long integer indicates the byte within the waveform description, which the synthesizer should begin producing sound. Yeah, we have to do something. The negative case, that's right. Pointed to -1 means that I believe. Yeah, I think it blocks. Okay, if completion run is pointed to -1, the sound will be produced synchronously. If it is nil, the sound will be produced asynchronously, but no completion routine will be executed. Otherwise, the sound will be produced asynchronously, and the routine pointed to by completion run will be executed when the sound finishes. Okay, so we're gonna go if completion RTN if sync while okay, real basic. I'm pretty sure the Z basic code does not use synchronous mode. It does it asynchronously. And I know this because I'm fairly sure that it does its own kind of waiting for, yeah, like it keeps polling the sound command to see if it's done. So in the interest of that, let's go to the game CPP. Yeah, okay, so oh right, no, like sometimes it waits, other times it is not so inclined. So I reckon we can just hack this up with unc5 return G toolbox sound done. I think that'll work. If it won't, I mean, it might work, or it might just create a horrible noise. And isn't that what we're here for? Come on, a little quicker than that. Yeah, okay. I made a typo there. Set sound vol and get sound vol. No declaration matches set sound vol and get sound vol. Oh, because I added the stubs, but I didn't actually add in a method. That's fine. We can do that. Start sound, stop sound, sound done. Okay. All right, where are we now? We have some grievances. Okay, no decoration matches. Audio PC speaker stream command. Okay. This thing which I changed. Did I? Oh well, audio PC soft synth PC speaker.cpp 30. Okay, byte volume. Mm-hmm. All right, well, it built. Time to just time to run it, and time to run it and enjoy. So I'll close this. All right, let's listen to. I don't know, judgment. Judgment? Buddy? Anything? Oh, I see. Okay, so up 8. Okay, the command queue is empty. So then that returns false. And then that should return. Oh, okay, right. So it's not. Oh wait, no. But then sound done should return true. Oh, okay. Yeah, I forgot one. I forgot one inversion of the negative. That's okay. I can go. So it really should be sound done 0, 1, and then this should. We'll call UNC5 sound busy. All right, this time it's going to sound awful. Nice and ugly. And judgment. Oh. It just played back really, really quick. Wasn't quite expecting that. Because I didn't. I wrote this API here. I did not end up wiring up to ZBasic, so this is still a stub. That is probably why. Okay, so easy. We can just go to toolbox start sound. Oh crap, yeah, what's the... Okay, so another little adaptory thing. Duration is... What units are duration meant to be in? So we got sound statement. Duration... Oh, come on. Okay, so ZBasic takes it in 1 millisecond increments. And yeah, this is in hertz as well. Okay. So we're doing some round trips here just so we can use this toolbox compatible API, but that's fine. I don't mind round tripping. Seven, 8, 3, 360 divided by frequency. If bail duration times 60 divided by 1,000, and then the volume is only used by the extended 0 to 255. Okay. Okay. How many bytes would it be all up? It would be 6 plus 2, so 8. We don't actually use that. And then we always call it with null, which is then asynchronous. Okay, here we go. Here we go. Oh wait. This frequency, duration, volume, and voice. Oh, whatever. It's fine. Judgment. What? Where's the... Oh, unimplemented synth. Okay, so I screwed up with... Oh, I understand, because it's uninitialized memory. I should have gone record mode equals case. I thought I added... Member initializer mode does not name a non-static data member or base class. What's the C++ism that I'm looking for? Hang on. Does not name a non-static data member or base class. Okay, no, you cannot initialize base class membership. Initialize a list listed because the order of initializer proceeds in this way. Okay, fine. So we just got to do it inside the constructor. That's fine. Assigning to synth mode from incompatible type int. Oh wait, no, it's just FT mode. Oh, sorry, SW mode. There it is. Not sure you can hear it, it's quite quiet. So somewhere I goofed up on the maths. Guessing on the duration. Okay, we better find out what's going on. This is also quite quiet though. Yeah, because we've got like volume 150. That should be like a lot louder than the stock PC speaker, right? Which is at volume 20. Like unless I'm missing something. Oh wait, did I turn... I might have turned the game down for another reason. Let me check my mixer. No, I did not. It's running at 100%. 100% volume. So... okay. Let's unpack what happened. So all of those are meant to be with a duration of like 40 milliseconds, which is to find a point on it, it's nothing. It is maybe the smallest unit. So we then convert that to... oh, okay, it's going to be something that doesn't... so 60 times 40 over 1,000. Yeah, it's like 2 milliseconds. Oh, sorry, two ticks, which is nothing. And then in the PC speaker, or actually no, in in the toolbox sound code. Okay. I mean, that was better than getting my first attempt at the sound working, which sounded... It just played all of the sounds at the same time, which was like a cacophony. But this is much better. It at least sounds like individual tones. Okay. So we got a... I got in the wrong order. Okay, so the amplitude, the volume was set to 2, and the duration was set to 150. That's gonna be a problem, isn't it? Yeah, that's on me. For assuming that the order of the triplet was the same as the order of Z basic. But it's okay. Okay, better turn this back down in OBS, or else you're gonna be deafened. Okay, let's have a listen. That was quite loud. Return to... Okay, maybe we're not quite ready for volume. Whatever volume that this gets set at, we should lie.
Listen and try it with the musical drum key.
Ah, thank you very much for the follow, Luca Cipriano. It's good to have you on board. Hopefully your ears don't hurt too much after that. I don't know. What's the nicest way of going about this? I think maybe it would be to go into here and then just lie. Okay, so the volume is fixed. So the volume, we'll say the volume was originally 150. This is crazy loud. Let's use the what did Mad Moose call it? The rectally derived PC speaker audio value. I mean, you know, it feels like a kind of like if you take into account like the logarithmic scale, it'd be alright. Luckily, there aren't like there's only one area in the code which generates audio. Okay, so let's try this. That's all good. Let's go to the word search. this is very satisfying. I should have added this in. I should have added this in much earlier. Okay, what's another place that uses audio? I think the Hermit? Yeah. I've done this puzzle so many times now. You have no idea. No. Okay, and then this is the bit where it makes you do it all the way around. I'll have one go at this. Uh-oh. Okay. Very carefully moving my mouse out of the way of the keyboard. There we go. No joke, I had to do that puzzle like 8 times in a row in order to debug something, and pains me to say it, but you get quite good at it if you do it enough times. Okay, good. Wheel of Fortune, does that use the sound? It makes a horrible noise if you click outside the area, but I think... No, it doesn't actually use the sound driver. Okay. Okay, excellent. Oh, I should probably try turning the sound driver off and then going to, like, Judgment. Yeah, okay. So, if you turn this guy off, you don't get it. Actually, I should probably... Oh yeah, and then there's, like, Justice... And like if we compare with like how the original sounds, the original sounds a lot worse, I think, because MAME doesn't recenter the you know, possibly the way the original Macintosh worked, it did not have like a square wave centered around the origin. It had like a biased square wave. I know the PC speaker driver does. I think it did in MAME at least. But yeah, when you have like a waveform that's not centered, or if you have like a neutral speaker state which is not centered, then you get like that kind of crispy crackling sound when it does recenter. But I just wanted to check if I go to Judgment. Yeah, Judgment sounds pretty much the same. And if I turn off sound and then go back to Judgment, there's no delay when waiting for it. Mamo says, have you tried the Mac emulator Snow? I have not. Is it any good? What kind of Mac? Are we talking PC, Power PC, or 68K? Oh my god, this is so much nicer than the sound that we're getting from AIM. Alright. Oh, 68K. That wasn't the one that was like a web-based one, was it? Oh, one other thing I should probably check before fooling around or committing this. Because I've been trying to split out the full commits from the ones that actually touch things in the rest of the engine. What I actually want to do is I want to make sure I didn't break AGI. Yeah, so these changes should be backwards compatible with every other invocation because the volume is a default, but in case they're not, yeah, it looks fine. Okay, so that's all good. All right, so where are we with the maze engines? So if I click here, okay, it immediately crashes. It immediately crashes because of a oh, because it tries to set with an invalid rectangle. Okay. Yeah, it's annoying. Okay. Oh, there's one place. There's one place that I use set rect. And it appears to have... Well, hang on. I mean, like, no. Those should always be valid. They should never... They should never be wrong. I mean, oh wait, draw rect is doing an invalid rectangle. And this is doing a stack overflow. Okay, so it's not... So it's... the rectangle is probably fine. It's just... me... doing... Oh, okay. Yeah, this number here is probably cooked. But it must be getting pretty high in order to be that cooked. No, stop. I've changed my mind. Changed my mind. Okay. Nope. Hedges. Okay. So what numbers we got? We got an interesting selection of numbers. So we have like 26 and 16. Oh. Oh, that can't be right. Why are these fixed? These aren't being changed. Oh, it's... Oh, these are going to be like... There's like an addition part that I've somehow sleepwalked and completely ignored. Hang on. Code 1636 00CA. Yeah. Alright, I am just bad at reading. So this code here is responsible for generating the grid that the puzzle uses. So the maze obviously uses, you know, it's a maze, it's a square grid. And then in turn, every square on the grid gets a rectangle, and this grid is then used for everything from like drawing stuff to the screen to aligning icons so that are on the grid to intercepting mouse clicks to check that they're in the right spot. Like, used for many things. But like every puzzle uses this grid pretty much. And it can be any size, dimensions, square, width and height that you want, and that's kind of what this kind of setup routine is all about. Actually, if it was overflowing, then presumably these increment and check values might be around the wrong way too. Yep. Okay. It crashed because of an overflow. Because I forgot to put in a stop. Okay, so we go to the maze. I go here. Okay, and then yeah. Okay, so A is the X direction, and it's bound by 11, and I think the increment amount is going to be 6. So 11, the increment amount is going to be 6. I mean, maybe I just underestimated how big this array has to be. It's a possibility. Oh, sorry, 1, 3, 8. Okay, so I put in 512. That may not actually be enough squares. That may not be enough squares. However, the polyomino code uses the memory 2F38. Wait, no, I'm an idiot. I can't do my 16 times tables properly. I'm going to go back to Professor Finkel. So 2F38 minus 1F38 equals 4096, which divided by 8 is 512. Okay, no, maybe I can do my times tables. 5 if var I16 484 equals 512. Yeah, alright. I got that far. Wait, what? Oh, yeah, okay. So notice how this is like still set to the very first values, because I should have moved these out by 1. Because every iteration of the loop, it was just setting this to the same thing again. Hey, Illuminatrix. I'd say so. We just got the horrible sound generator working. It's sounding quite nice. In fact, most of the game is working now. Just down to the maze and the end game. So like, if we go into here, so audio, which we didn't kind of have before. Ooh, I wonder if the High Priestess does audio. I can't remember. Yeah, so this puzzle is pretty notorious. You have to click on, well, the first part is you have to click on all of the numbers from 99 down to 1, which is not a secret. It tells you that in the description. But then the flashing progressively gets faster. Previously, it would go like all the way down to like flashing at like 60 hertz as soon as you got down to 1. I changed that to make sure that it was capped at like the WCAG recommended of like 3 full cycles per second. But oh yeah, and the fun part is, you know what? Let's just trace through it. Let's show how fun this particular puzzle gets. Okay, so 96. Okay, where the hell's 95? 95. So if you click anywhere, then it just kind of like puts garbage on the screen, which can be helpful because the very first number that turns white is the one that you want. But like sometimes they're just really good at hiding. 94. Where is 94? I mean, I know 93 is here and 92 is here. 94. There we go. Okay. 93, 92, 91, 90, 89, 88, 87, 86, 85. And yeah, I had to do this. I also had to do this particular puzzle many, many times to debug a bunch of problems. So, yeah, that's kind of helped. 82. $79, $78, $77. Where's 75? 74. So yeah, it just kind of goes on like this, and Illuminatory says this makes my head hurt. Yeah, the same. Like I had to, because yeah, the original on the original Macintosh emulator, like the speed that it eventually gets to just gives me a migraine. So I made the executive decision to reduce the flashing by quite a lot. But I want to get up to like this. I'll get up to like this next bit, and then we'll stop. But you may be kind of thinking, oh, where's 69? There it is. 69. 68. '67, '66. Oh, here we go. 65, 64, 63, 62. 61, 60, 59, 58, 57, buddy. Oh, there you are. So you may be playing this and you're thinking, hang on a second, this is easy. Like, you know, the more enchantments that you click, the fewer numbers that there are, and then like the easier it is to just kind of find the next number, like 49, 48, 47. Okay, the flashing is kind of really irritating, but you know, it's not impossible. 43, 42, 41, 40, 39, 38, 37, 36, 35, 34, 33. Ha ha ha, surprise! They now move. So it's flashing. The flashing is getting faster. And now, so low-key, I think the trick to this is that, like, the number that you're looking for sticks around for just a little bit longer than the other numbers, but all the other numbers are like moving at kind of the rate of how many numbers that you've got left, which is quite high. And usually, and you've got to kind of just like find a corner of the screen and then focus on it for like the number that you're looking for. Anyway, I'm not gonna do the entire puzzle but just take my word for it, it gets really painful when you get down to one, but it is possible. And this is this is making it more fair compared to the emulated edition. But that's like a wonderful stress test of all of the Macintosh monochrome drawing modes, which this game loves to use. But apparently, yeah, okay, that doesn't use the audio chip. Does Temperance use it? Oh, it does. Nice. Okay. Well, let's put that to one side. Okay, so back to, oh yeah, that's right. Now that we fixed that, hopefully that memory overflow, we should be able to open up our saved game. And wow, okay, that actually drew a lot more than I was expecting. So this is the start of the maze code. To escape from the maze, use the mouse to maneuver the white dot to the exit. As you can see here, there are a lot of stubs because I've not quite filled in the blanks as I should have. So in the interest of just like getting something on the screen, let's just go and fill in the stubs and see what happens. 2582. Oh, that one's actually quite tiny. 2582. So yeah, for people unfamiliar, what I have here on the right is Motorola 68000 assembly language. This is originally a ZBasic program. I have disassembled it using just a crappy disassembler that I wrote that identifies like ZBasic commands. So like, for instance, this one here refers to left S, which is a string command, which you can see here in the so like, yeah, here's the ZBasic manual entry for that. But you know, this points to a function in the ZBasic jump table, which then we can, you know, we don't have to emulate that specific, you know, exactly. We can just look at this manual here and say, oh, look, it's meant to chop up a string like this. And then we just do that in C++, which is less painful. Kenigo says, so I just learned how to use IO setup to mount the raw FAT16 disk image I made for PCM to shove shit into it, just to get 4DOS, CuteMouse, and DOS idle installed through that method. Okay. Oh, low setup, sorry. Yeah, getting the loopback device. Yeah, it's basically the method that I use for copying stuff to like the disk image I use for MAME. So loopback setup is quite useful. I don't know how people live without it on Windows. So 136.2582. I'm putting in these little comments here saying like exactly where in the disassembly is, so that when later on I go and change these to be something that can be readable by human beings, I can still look up where we are in the disassembly if there's a bug. Interesting. Okay, so var i16 1e06. Okay, so anything that uses decode int needs to be non-Unicode, or it needs to be, you know, it's not a string describing text, it is a string describing bytes, or it's a string with bytes in it. So 1ac8. Yeah, okay, we've already got that marked down as bytes rather than Unicode, so that's good. Okay. Times 2 plus 3. So yeah, ZBasic, I don't know, it doesn't really have like a good concept of, I mean, you know, it has limitations. One of the areas where it has like the most flexibility is like storing strings or copies of strings. Like you get a whole dynamic lookup table just for string data, and so this game will quite often use strings, which are they're like they're Pascal type, so they've got like they're prefixed with the length, so you can store any kind of data you want, null or no null. So that's what this game does. Unfortunately for me, when I was kind of setting out on redoing the Toolbox API, I thought, hey, wouldn't it be cool to use like the U32 string class, which is meant to be like a Unicode, it's meant to like be an encoding free Unicode happy joy type string class, except you then run into like issues when you're converting between that and Macroman, which is especially if you have like arbitrary binary data, because when you convert, I don't know, with the ScumVM string casting API, it'll just ignore the nulls, and that's a big problem if you're trying to decode bytes to and from. So we have to like be very strict about what is a U32 string and what is a normal string. So anything that uses decode int, which is basically like lifting an int16 from some string data, that's got to be the bytes type. That can't be the Unicode type. Okay, so 25CO. Okay, and then it's a loop. We can do that. Yeah, you also have to be careful because all the variables in ZBasic are global. So sometimes this loop counter, like 68A and 68C, are quite often used like as you would I and J loop counters, except sometimes they persist across. They're not scoped to a function. They persist across calls. But in this case, it is just local to here, and there's nothing outside of that, so it should be safe to turn that into a local. I16.1E06. Okay. Yeah, okay. I think that's about right. Is there a... There's no... I'm gonna have to go back on... Like, once the entire game has been converted to C++, it'll be a case of like going through and seeing, like, for instance, like these variables here look like they're only kind of referenced in here. If they are, then great, they can just get turned into locals. Otherwise, but you know, but for that can only really happen though after we've copied like all of the code. Before that, we just gotta track it. It's 16. Okay, how does that change anything? Does that change anything? Okay. Oh, and we crashed it. Oh, that's what that draw oval command is. Okay, so there was like one piece of the code which I didn't quite understand, which was some code which just seemed to draw like an oval on the screen in a loop. And I was like, why would you want that? Who's that for? And I think I've got my answer now. It's to represent the character moving around. I guess because, yeah, all right, I haven't finished translating BOO yet, so that's going to be a problem. Huh, okay, but also the oval shape seems to be bad. 21, 21, 12, 12. Yeah, okay, so it takes this pointer, it then passes that to invert oval. Did I get the math wrong there? 1E8, 1EB8. 48. I got it very wrong. Okay, so it was actually 24. 24, 25, 26, 27. Oh, I see. Okay. So like this method here, I think was doing a bit of code reuse from that. Like it's one like most of the like 99% of this code is very good basic code. There is no go-to. However, this I think there is an example of code which I think is only possible via go-to. So we might have to like just fake that by copying the code twice. Cancel. Open. Whoop. Oh, okay, now it's now it's 0. Interesting. 1E8. Minus 1EB8. Oh, maybe there's like an earlier piece of code that was meant to load it into the array, but that didn't happen. Okay, so like it reads up to 23. And then the code down there specifically goes from 24 up. It's gotta be deliberate. $15, $16, $21, $17. Yeah, and then this guy down here, which just accesses 24. Oh, okay, that's a method I haven't transcribed yet. Okay. Okay, that's the maze of hedges. What does the other maze look like? Archway. Okay, the archway looks... I don't know why there's this big kind of rectangle down that side. That doesn't seem right. Okay, and then the moving part doesn't work because of obvious reasons. Okay, well, let's a bit of work on the pathfinding bit. Oh, right, there's a method immediately after invert oval that I missed. Okay, and then I wonder if it was actually, if the coloring was right. I don't know, my strongest memories of the PC version, and the PC version I'm pretty sure had like cyan or something. Okay, no, looking at this walkthrough, it is indeed meant to be black on dotted, so that's fine. There isn't meant to be this kind of weird column on the left hand side, but we can deal with that in a bit. The maze itself looks like it's been drawn okay. Okay, that's a new function, so 136. Oh yeah, on EV8. 24? Yeah, 24. Okay, top plus 4. Ah, okay. So this is how the coordinates for the little circle get moved around. I understand. I see how it is. Okay, so this becomes 25, and then becomes left. Bottom. Right. And the bottom, I imagine, subtracts 4, and the right subtracts 4. How about now? Okay, archway. Ooh, interesting. Didn't lock up there last time. Why is it locking up there? Oh, would it be locking up there because it's trying to... interesting. Fin. Where are we? Okay. How... okay, that's not... It's not ideal. It's not ideal. So I would have thought that... I would have thought the little marble would have shown up. Like, in the bottom... Like, bottom left corner? this looks weird. I gotta figure out like how I screwed that up. I think. Where is that? Okay. Oh, I probably did like another math screw up again. Knowing me. Yeah, okay, I'm off. Again, I'm off by like factor of 2. So that should be 22. And yeah, it takes that number, it pushes it to the stack. It then takes whatever this is, and then it ORs it. So... Okay. All right. Well, that's... Yeah, okay. There's something about that that's making an infinite loop. We'll get... I think it's been 3 hours. We'll get back to this after a quick break. I'm going to go get myself probably a tea and then maybe a little snack. We'll see. But then after that, yeah, I guess we'll just come back and keep hitting at this with a pointed stick until we get to a working maze, hopefully. I'll be back about 5 to 10 minutes. Go stretch. that's enough of that. Right. Why is this doing it? It was fine. It was drawing the maze and everything, and then we fixed a bug, and then that evidently got something else unstuck. So I had like a little bit of a... I found there was like at least one area where, like here, for instance, this was... I forgot to change the loop variable here. So this technically was wrong the whole time, but that doesn't give an excuse for the rest of this. The rest of this code. What gives? Okay. We're just kind of perpetually stuck here. And this kind of baffles me. ABE. So this is, so BDA, okay, so I've made a typo. That's not going to help. All right, so it's not even a do while. Because, oh, I see. Okay, so it might be like a double-headed function, and like ADE is meant to... Okay, let's just really unpack what's going on here. So we have a comparison here between BDA and 1574. And if they're equal, then it breaks out. If they're not, then they circle around again. Okay. Okay, there are a lot of places. Okay, BD8 is definitely set properly here. And then if I were to like just do a spot check in one of these later ones, like 2D4C. Yeah, okay. So that's right. The variable naming system usually works, but if the names are phonetically similar, sometimes I screw up. Like 8 and A is the one that always kind of keeps shanking me real bad. Anyway, I think that should help. It may not stop the loop, but it might. Oh, that's right. Did I... Oh yeah, I did duplicate that call to 2664, which I missed the first time. Archway. Okay, good. The pattern down the bottom, I think we can agree to disagree. That doesn't look like right at all. Clicking on the maze doesn't really do anything. I can leave. I can quit and return to the scroll, which is... Oh, okay. We can move around the maze. That's kind of... It was just... the initial place that we showed up doesn't seem to be rendering properly. Also, that's a crappy oval. I'm sorry. Like, why? Yeah. Why is the edge getting shaved off? Like, all the edges are getting shaved off. That is most odd. Yeah, okay. I get the feeling that... So my recollection of how this is meant to work is that there's meant to be all of these little traps that get triggered as you move through the maze, so it's not as simple as just, like, navigating it. Also, there's meant to be little kind of messages down the bottom taunting you. Neither of those seem to be happening, so... Alright, what to look at first? Okay, initially I think I must have got the offset wrong for that pattern. Okay, so there's a few spots which set the pattern. I think the one that fills that rectangle down the bottom is... Yeah, like that should be done with like... Oh wait, no. So fill rect. Okay, it happens in 2 spots. Oh, okay, and there's this one here which uses this variable. Okay, and that's specified here as this number. Okay, let's just commit what we got. Ah. Okay, then we can get rid of this. We don't need that anymore. Don't need this anymore. And then I want to open up toolbox, and I want to go, well, actually not that one. I want to open up quick draw. I want to have a look at like the output of the oval drawing code. Because like the other thing that kind of throws me, right, is that like if we go to like the children, I think the children is one which draws like, here we go. If we go to the children, Oh, wait. Okay. No, we can't. If I open up a new game and then I go to strength. Nope. The world is a word search. Oh, interesting. Okay. That should have destroyed the puzzle data, but it has not. At least not for those other two puzzles. How strange. Not Hanged Man. Page of Cups? No. There's a specific puzzle type that I'm looking for, which was there with the children, but I think one of these must be it. Empress. No, not the Empress. Not the star. Not the chariot. Sorry, we're spoiling a whole bunch of puzzles. Because, hang on, if I just quit and then open this again. I think what's meant to happen is that starting a new game should have wiped out the saved puzzle cache, but I guess it didn't. Okay, is it Hanged Man? No, Hanged Man is a puzzle. Hierophant is also a puzzle. Moon is one of these. No, I'm looking for like a sentence. There's like a sentence structure-y type puzzle. No, death is its own thing. Devil's another jumble. Judgment? No, Judgment is one of these. Empress is one of these. Okay. Actually, maybe I can just go to an earlier game. Nope. No, that's too far in. The blacksmith? No, it's another jumble. I mean, this is closer to the children. If we just do the Knight of Cups. Okay. Ah. This puzzle is considerably harder if you have a keyboard with no keys on it. Okay. What? You mean I don't get the children after the Knight of Cups? I go instead to the stupid Queen of Cups? Alright. That kind of bites. The Dream. I know the Dream is another one. Maybe if we do the Knight of Swords, we can get to the Dream. Okay. Okay. Good. This again does not get us where we need to be getting. Do I have another save game? How about the humbug? The humbug. Yes, okay, so let's just solve the chant. Okay, dream. Alright. So, the dream uses the oval drawing API. Those all look like ovals. Why are they fine? I may as well save this and just to double check. So like those are fine, whereas if I go to the maze, I don't know where I start in this maze. Anyway, okay, so it's a good contra example. We are going to put in ah, crap. I didn't mean to do that. Oh well. Archway. Okay, so we start down here. Yeah, like looking at this picture. Yeah, it just feels like the oval drawing algorithm really didn't okay, so the rectangle that gets loaded in is a 13 by 13 rectangle. Which should be more than fine. Perhaps yeah, okay, perhaps it's like the the oval drawing algo that we've got. Oh god, this happened again. Alright, so he uses this nifty formula here to Bressenham an ellipse. And if we look at kind of the output here, what have we got? We've got yeah, it just doesn't look very good. Like, it would look slightly better if you kind of restored this line and this line, but then that corner would also be off. How's it actually calculating the... Okay, so we've got like the width and the height. So like, here's a screenshot from what the ellipse kind of should look like. You can see it's kind of like a, it's kind of like an octagon, like a stop sign. Which, you know, I guess it's fine. Okay, and yeah, like so it draws the ellipse as a series of horizontal lines. Which I guess makes sense. Okay. Well, I can't fault it for its efficiency. Like, it doesn't rely on any kind of actual yeah, I guess it just uses kind of like approximation to figure out what the edges are, but I mean, doesn't look great. The 13 by 13 one does not look great. And like, it looks close, right? It looks very close to the one that QuickDraw has. Actually, I mean, like, does the one that QuickDraw has, is that just 12 by 12? It's very difficult to tell. I swear to God, this mouse wheel is going to be the death of me. Interesting. Okay, so it just rendered it at 12 by 12, which is a choice. Oh, no, it did not. It rendered it at, oh no, it is 13 by 13. I just a dunce who can't count. Anyway, whatever. That's minutiae. The real problem. Let's be honest, we've got a couple of problems. Okay, one is that, like, oh, another thing I've noticed is that these walls are too thick. Because, like, if we look at the reference photo, they should be at most 4 pixels wide, and that's why the bottom of this circle is touching the wall. So let's look at the wall code. I think I might have, good chance I might have just messed up an offset there. Full mazed.cpp. Yeah, like here. So we have these methods here, which are all doing like relative offsets. Okay, let's just read them. 2A7C. Okay, so we have left -2, top -2, left -2, bottom -3. Okay, so that one's fine. Left -2, top -2, right -3, top -2. Okay, right -3, top -2, right -3, bottom -3. Left -2, bottom -3, right -3, bottom -3. Okay, left -2, top +3, left -2, bottom -8. Left +3, top -2, right -8, top -2, okay, right -3, top +3, right -3, bottom -8, and this final one. Left +3, bottom -3, right -8, bottom -3. Okay, so that must be all right. All right. So all of those seem fine. Okay, yeah. These are wrong. Once again, I forgot to convert a loop counter over. let's turn off. Okay, what we want to do is find out which draw command is responsible for drawing the walls, and once we get that, we should be able to see why the walls are extra thick by like a pixel. Okay. Archway. Okay, well that's that's a lot of commands. Oh, a lot of useless commands because this is relative to the surface. Okay, that's not going to help. Where's the thing which updates PN lock? Yeah, I understand now. I see, so it just draws these lines as like little... Literally each wall is a line. That's okay. It seems like all the horizontal walls have this size problem, so we should be able to narrow that down somewhat. How about that? Okay, so the maze of hedges, all the walls are like 25 by 5. But this other guy, the archway, okay, the archway is also 25 by 5. But I don't get it because those walls are at least. Oh no! Okay, no, they're 5 pixels thick. They're 5 pixels thick if you kind of because of the offset. But now I'm wondering, like, okay, are we really off by that much? It's like this reference image, we've got 1, 2, 3, 4 dots. Here we've got 1, 2, 3, 4, 5 dots. So like maybe we're off by like 1 pixel. Please. Okay. Okay, let's measure the gap on the right hand side because that seems consistent. Okay, and this is 512. So let's just crop display to what we know. Image, crop to selection. Oh right, because it doesn't have the bit at the top. Okay, image, crop the selection. So if we measure what's going on here, ours has 17 pixels on the end. Theirs has 17 pixels on the end. How many pixels high is the menu again? It's about 20. It's 19 really. And there's a 15 pixel gap between end to end. Whereas this is a 17 pixel gap. Because these two rows are erased. Mamu says, "Are you drawing the pattern in the wrong bit order?" That is a good question. I don't think I am. Because I mean, like the pattern bit order here matches the pattern bit order up here. I think what's happening is that there's a difference between how the Bressenham algorithm is dealing with lines. That's just subtle enough to kind of hit us here. Because like, yeah, because these... I mean, alright, let's look at some exact figures for drawing lines. So we have like weird how it kind of draws the same line over and over again. That's not something I would have expected. In fact, that's very suspicious. Like, why is it drawing the same line over and over again at the same position? That seems wrong. But yeah, start pause is 94 by 264, so we'll find that. 94. Oh, please, come on. 264. Really? Okay. 94 to 264. Which should be here. To 94 by 284. Oh, okay, that's drawing a... Okay, that's drawing a vertical line. It's still drawing the same thing over and over again, which I dislike. It's also it's using this pattern. It shouldn't be... Like, none of this... It should be all AAFF, AAFF. Yeah, this guy. Okay, this is more like it. So we're looking for something which is like a horizontal line. Okay, these are all horizontal lines. Okay, so if we pick 414 to 224 and 434 to 224. Which is a 25 by 5. Yeah, okay. So it's like this size of segment. So in order for it to line up to the pattern, that seems fine. Also, let's just look at the pattern under the microscope. So we've got 1 0 1 0 1 0 1 0 1 1 1 1 1. That makes sense because 1 in Macintosh Ease is black. So I mean, that would imply that the very first pixel on the line would be black, then white, then black, then white. Which... Okay, maybe we're gonna have to just double check in the emulator. Oh, Kinnick says, well, I'm pissed. No matter what Pentium I set, and setting the correct setting of the speed model and TMX setup utility, there is no way to get the game to run at a proper speed. It just speeds up like hell and slows down to a crawl at a whim. PCM cannot save this cursed MS-DOS port. Yeah, I mean, you can't win them all. I imagine that, like, for... I guess more accuracy aimed emulators like PCM, the downside is that, like, sometimes all of the layers of extra hacks in DOSBox mean that games like this can work better or worse. I don't know. Depends on the game, really. What am I doing wrong? Am I off by like one? What does the Maze of Hedges look like? The Maze of Hedges uses a different checkerboard pattern, interestingly. pattern. Yeah, okay. And then like the horizontal starting position, or sorry, the vertical starting position of these lines, these horizontal lines, it's always even, which then means it always starts on a dot because the first row of the pattern has dots on it. Okay, what's the easiest way to... okay. Because I don't really have a save game in the emulator that's near the Maze of Hedges, and I don't like my chances in converting these existing save games to get there. So maybe we should just put a pin in this rendering problem for now until we've better sorted out what's going on. Interesting, okay. So what happens if I try and... So I'm pretty sure at some point we should hit a stop. Oh, what am I trying to do there? It tried to fill in a rectangle with a weird pattern at 0 to 310. Yeah, okay. We're missing heaps of stuff. That much is for certain. Okay, so why is this getting clipped out? Like, this should absolutely fill that bottom quadrant of the screen, and it's not doing that. Okay, so... yeah, so it's drawing a 28 by 508 rectangle. Don't know why it's skipping 4 pixels. Either or. Oh, because of the pen size. Yeah, okay. Okay, no, the intermediate is the right size. And the destination rect is the right size. Okay, so... yeah, and it adds a dirty rect for the default window. Oh, is this using... is it because like the pattern... oh, what is the pattern? The pattern is like CO, 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 CO. Which... I don't think it would... oh, actually, maybe it is this kind of weird column pattern. Which I guess would imply that the pattern is wrong. But it's set there. Did I screw that up? Yep, I did. I mistook B for a D. $34 divided by... I think it's 17. Yeah, okay. Yeah, 1 EB8. This array is quite annoying. Every puzzle uses it for like storing data that it pulls out from the puzzle data file, and sometimes it's rectangles, sometimes it's like other pieces of data, sometimes it's pattern IDs. There's no consistency, so yeah, we'll eventually have to change that to useful variables instead of I don't know why it's like 30 bytes. Oh, sorry, like 30 words. I don't know why it insists on reusing it. Possibly because then it's in a format that's easy to just load back into the save state when you save the game. But yeah, it's frustrating. Okay, that's the maze of hedges. And then we go to the... oh, actually, yeah, there was one other thing, which was... what is going on to create that void on the left-hand side of the playing field? I'm guessing it is this initial draw rect call, which... no, but it can't be though, because that starts at 105 by 295. It's a very thin rectangle. Oh no, these are all ones that just kind of draw the... yeah, okay. No. No, this is our guy. So I believe that this initial call here is going to be wrong. So we've got all these set rec commands and then the playing area. Okay. So potentially I messed up the left boundary. Yeah, I did. Okay. Left. Did I also screw this up? Like, is this also meant to be 0? Let's read. Okay, 1 EDA. Oh no, that's okay. That's cool there. One F40. Okay, so that's index 1 from 1F38. Okay, and then this is the left of index 1F38. Okay, and then like bottom and right. Like, what's the deal there? So we've got 1EB8 multiplied by 1EB8 1, subtract 1. Okay, then that's dereferenced to be like the bottom. Okay, and then for play area right. Okay, yeah, we've got 0, then 1, multiply together, subtract 1, dereference to get the right value, and then subtract 3. Okay, so that should get rid of the void on the left-hand side. Mamu says, I'm amazed you're getting anything right in this manual translation. I couldn't do that. It comes with practice. You start to... your eyes kind of defocus a bit, and then you get very good at translating like array calls to C++. It's worked pretty well so far. Seriously? Still a void? Even after changing the... Wait. Well, bollocks. Okay, how about if I put a breakpoint? Full maze, CVP 84. Okay, return to the scroll. Then come back. Okay, so the one that... So, index 0 appears to be not correct. Did I just do an atrocious job at reading this? One F40. Oh, no. I missed this. I missed the addition. Okay, because this is... Okay, this is like a pointer that's been baked in. This is adding 4. Sorry, starting with 4, then adding 1, which then like sets which field of the rectangle, and then shifting left 1. Okay, so that was... It's on me. That was... I was like wondering like, why is it going like 1 and 0? That doesn't make any sense. Especially seeing that rectangle, we don't actually set index 0 for that array. Okay, this should get rid of the void. Okay, open. Crap, not dream. Despair, that's what I want. Let's go to archway. Okay, much better. So that's at least, that's closer to what it should look like. Now, did at any point we draw an oval? No would be the answer to that. So that's not ideal. Where are we now? We're currently in wherever the hell this is, 161. Okay, but before that, we should have made this call to ADE, which I'm pretty sure that the whole point of 2664 was that it draws the oval on the screen. So return to the scroll and go back to the archway. Yeah, it draws an oval on the screen. So PG toolbox, just so we can see. So yeah, the maze has been drawn on. No objections there. Yep, then we got our oval. Huh. So why didn't that do anything? Like, that should have drawn something to the screen. Yeah, okay, so it's created a 13 by 13. Okay, maybe the quick draw code for like inverting is busted. Like, I deliberately kept I deliberately basically made it the same every single time. Oh, wait. Oh, okay. That would probably be because I didn't use mode. Yeah, that'll be why. That's a bug. Alright, any other these guys up here that I didn't use? Oh, yeah. Okay, another bug is that I didn't use frame. Quite sloppy, in fact. Holy shit. Okay, we did convert the pattern. We did, but we didn't add in a branch for frame. Like, what's the dealie? What do we do for pretty sure frame is just a. Oh wait, no, frame is frame an argument to. Yeah, okay, no. I'm overreacting, it's in draw ellipse, so it was just the pattern, or just the mode, sorry, that we missed. So how was it drawing it before then? I thought all the code was using invert oval. And yet invert oval by definition couldn't have worked. Oh no. Invert oval could have worked, but it was using the leaked mode that was in the pen. Which, so if the pen for whatever reason was set to Zor mode, then it would have drawn the little guy, but it wasn't, so it didn't. Okay. So I keep picking the largest number, and really I want 38 because that's the highest save game. Archway. There we go. Little guy's showing up nicely now. I may actually start this again without all the debug spew, because I really want to keep an eye out for stubs, because as soon as we hit a stub, then that's code that I need to, because we still haven't like typed up a large chunk of the maze code. I mean, it's actually doing like collision detection, so that much is working. But I'm pretty sure that the challenge isn't meant to be get to the end like that. Like this. The stuff which is meant to knock you off course. But somehow we're not encountering any of that. Okay, well, I'm pretty sure that B00... I mean, B00 was getting called last time. I guess we'll just keep filling in from here. Yeah, like this gets called like all the time. Which makes me suspicious. Like how? Oh, because it's getting kicked out early by this check, maybe? Interesting. So I think var 1574 is meant to represent the current grid square we're on. It's like it's 157 now, but if I were to like move down to here, yeah, it's now different. 182. And like if we look at this array, we can see that there are cells which do not have this flag on it. I believe these flags are pulled from the puzzle data. Yeah, okay. Wait a second. How? This seems wrong, right? Because we got all this abundance of numbers here, and yet from my jaundiced reading of the code, it should be reading a single byte. It should not be reading 2 bytes. It should not be reading a 16-bit number. Unless, of course, there is code which gives it a once over and changes it at the end. I'm gonna double check that. God, this is definitely the most screw ups that I've made when transcribing a piece of code so far. Okay. Increment 484 by 1. Index this into 3738. And then call 428, which I think is 428. Yeah, which is reading a byte. Okay, so we got like these methods here which check like the not quite the not quite the high bits, the middle bits. 2A 7C. I see. Okay, and then they go ahead and set these other bits and pieces. Ah, here we go. This is our guy right here. So we have 2582. It picks like a random. Okay, it picks like a random square. And it sets this flag. Okay. What do we say if we like started up from like the very beginning before 2582 has had a chance to run once? Actually, no. 2582 runs. It kind of runs here in the constructor a fair amount of times. Interesting. Okay, so we've got a loop index here. Did I maybe screw that up? Is that meant to be using... I don't think 2582 uses... Unless, of course, this is... Okay. Let's just double check. 5EC. Also, what's the significance of 29A? 666. Okay. Okay, if it doesn't equal, then it goes into here. Oh, here we go. 1 BCA. So I'm pretty sure 1 BC. Oh, 1 BCA not used anywhere else. Really? Okay, no, it is genuinely just used for this loop counter and nowhere else. It calls 2582. Okay, so like here's an example of just some some wonderful string data that has been pulled out of presumably out of the puzzle file, but it's okay. Okay, so that's good. We shouldn't be losing anything in translation too much. Oh, except we kind of are. That should be raw. Okay, that uses index raw. That uses index raw. I mean, there are still nulls in it, so I must have tried to convert it. Archway. Okay, so where are we now? We're about address 60. But like looking at this, we can see that like this index here, like index either 1 or 2, has no thousands digit. So that's a good candidate for making it past this check. Except it doesn't. Okay, literally the very first element. Yeah, 4096. Oh wait, no, it's checking to see if it's been set. Okay. Gonna double check to make sure that I didn't double negative screw that up. Yeah, okay. So we AND with 1,000, then we check to see if it is equal to 0. And then if it's not equal to 0, we do a bunch of stuff. But if it is, okay, but if it is equal to 0, then we short circuit and leave. Okay, do any of these numbers then have the bit? Doesn't look like it. looks like it wasn't applied to anything. So that's okay. That's probably something to go on then. I mean, this function was written, oh sorry, it was like called a truckload of times. So something must be desperately wrong about that. Return to the scroll. Go back into here. How many... Okay, so it's going to... Alright. Then it generates a number... Oh. Okay. It generates a random number between... Oh, I guess 0 and 0, which then means, I'm guessing then the knock-on effect of that would be that, what's in here? Oh, it's just the number 0, so this just isn't filled out at all. So, okay, so it's just index 0 that keeps getting filled up over and over again. That's adorable. 1df2. All right, but it's like it's looking for other. So this code. So this code counts the number of times it finds 1,000. Oh, sorry, hex 1,000. And then based on that number, that's what it uses to add another entry. And then that in turn uses this 5 VPC array, which does not appear to be populated at all. Yeah, it seems a bit sus. What's... Oh no, okay, but that's being set using this. Okay, so 5 BBC appears to be like the random choices of... Okay, this is probably cooked. This is... that's my bet. My bet is that I've screwed this up and it should actually be checking to see if that's 0. So if we like look at that particular piece of code, yeah, that's where I screwed up. Okay, here we go. We got there in the end. So there we go. So if the tile does not have the magic flag attached, it then gets put into this list here, and then a random choice gets picked and gets marked with that. Don't know for what, but anyway. Let's see what difference that makes now. Hopefully we should be able to get some more angry stub messages, because I haven't written all of B00 yet. Because this will definitely add a lot more of those flags. Yeah, here we go. So we've got, at the very start, we've got, yeah, okay. So you see how when I move to this particular area, there is a stub message. That's because something is meant to happen in the maze when you get to that point. You're not meant to just be able to like traipse through to the end. Like you get whisked around and stuff like that. So, okay, that's good. Now we know that we have to keep going on from here. Yeah. Yeah, I mean, we could have just kind of keep typing regardless, but really, this is useful because now at least we know that if there's code that's missing, and we're not reaching it, or we're not reaching the bits that are missing, then yeah, we've screwed up earlier on down the track. So it's good to kind of check in frequently to where we are. So where did B5E, all this stuff here, return, okay, so that should be B88. Okay, then we got a jump, which probably implies that there's going to be a while loop. Cool, a huge switch statement. So we'll say while var I16 1 CDE is greater than or equal to 0. Crap. Okay. +2 1. Ooh, is that actually used elsewhere? Oh no, it's just used in the maze. Okay. So if this equals oh, cool, there's another loop. Yeah, which is just checking this. So for int 16 I equals 1, I less than or equal to stir 1bd size I plus plus. Push that 1AC8. +3. -3. Equals G Z basic. Oh, okay. I think I got the ordering of this one around the wrong way. Actually, what we could do, seeing as it's cropping up a few times. but that's just like reference. That's just returning a reference to something in the fucking list, isn't it? Wait, no, that can't be right. No, it does return a reference to the data in the table. So I guess we just go const common string basic. Yeah, because like I guess where we're kind of like coasting along is that stuff that's in the zbasic string table has got to be like, you can't put nulls in it. It's got to be something you can cram into the text editor, I'm pretty sure. I mean, that's, you know, there's a chance I could be wrong about that. Should have done that a while ago. So what was this code here doing? It was comparing these things. So if it does equal, then do this, else. Okay, then we have a massive switch statement. Okay, 22 lines. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. And 1 for luck. And by luck I mean default. I'm betting that these are going to be all of the different things that are going to happen when you wander around in the maze. Yep, okay, we got exactly the right numbers, number of options, so let's... Okay, and then we get to D54, which is out of this switch. Okay, and then that's the loop condition. Okay, let's see how many compile errors that makes. It's going to be a lot, because we're going to have to add stubs for all these functions. I mean, I reckon some of them, they look pretty small. Like if we were to look at like 1932. I don't know. Like there's an argument that could be made that you could just jam them into the switch statement here, but they seem... Whatever, we'll just have more functions. Sub 136. Okay, I'm just gonna add a crap load. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. D64. E4C. ED8. 74. 15A. 137C. 63C. Okay, I got one extra. Oh, I missed one. That'll be why. Okay. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. Okay. Okay, once again, I've missed one function from the list. If we compile it, we'll find out which one it is. Oh, and a couple of new variables. CDE. Okay. No matching function to oh, okay, because yeah, I got the arguments around the wrong way. Okay, so this code here. So push. Yeah, so push the string. Then we push one CEO. Oh, and subtract this. Yep, subtract one CD. then subtract the number 3. Okay, linking error. There we go. 1898. That's the one I missed. Okay, so now when we move through the maze, we should get a different stub depending on what thing we wandered into. Nothing will happen, but we should get, we'll at least get some feedback about. I mean, we can then just start filling in the blanks really and seeing what happens. Making the best use of the time we have. Okay. Open despair. Wait, what? Okay. So by adding more detail, we've in fact uncovered more places that we need to fill out. D64 and 1898. So these are both... Okay, well, we can quickly do those. Ooh, alright. There's instructions that we don't currently support. Wonder what that is. Oh, it's a trap instruction we don't support yet. That's novel. What trap instruction could that be? Yeah, okay, so we got like these trap words. But they all begin with like A0 rather than 0A. At least like for these kinds. Oh wait, did I type into the disassembler wrong? 0A800000. Yeah, okay, it's just an invalid instruction. Which I guess would imply it. I mean... Alright, no, there's a way of breaking the tie, and that is we use a better disassembler. Yeah, I'll shut it down. Don't crowd me. Okay, so if we go into the code segment and we go into code segment 136, and then we scroll down to 18E6. That was pretty close. Oh, okay. It's an exclusive OR on a long. I don't know why this 68K didn't figure that out. I kind of should have. But I better add that into. Better add that in. There we go. Fixed. All right. So we can go 1,000. Yeah, it's just setting it. Okay, that's quite important. What was the other D64? Okay, no, if they do equal something, yeah. Rather, if the output from this equals 0, then do something. But otherwise, yeah, okay, just do an early return. That works. Oh, this prints a little message on the bottom. They see 0 Vic. Wait, no, but that's... Oh, if it doesn't equal that, so if it's not empty, yeah. If it's not empty, then jump to here, okay. String width. Divided by 2, subtract this. Okay, yeah, that divided by 2, then subtract from that. Then push that 1F for F 10F. It's pushed. Divided by 2. Oh, it's fill rect again. Okay. Oh, because it's filling a little background for the text box. Yeah, okay. Okay, and then out here, is this used in any other? No, it's not. Okay. 1578. Oops. Oh crap, it is used in other ones. Okay, no, we can't change it. We can't change it. I guess we're gonna have to. Okay, how far will it get now? Will it crash immediately? Will it loop forever? Will it do something else? It'll loop forever, is the answer. This looks bad. What's on line 387? Yeah, okay, so that's one CD. I mean, why is that even converting from U32 string at all? That shouldn't be happening. Yeah, so we've got this string. Is that what this is? It's just converting it. In real time. Oh. Oh, is it because like the insta? Oh, I see. Okay, it's because I haven't got. I I didn't make a... Yeah, I see. Okay. That'd be why. I could probably make those templates, but... But yeah, the casting to U32 string means that all the nulls get... all the zeros get treated as nulls and just ignored, which is bad. Okay, despair. Archway. Okay, well, still spinning forever. It seems to be in this very specific block of code. Maybe this conditional here I screwed up. Like... So look at D54. Basically, if it's greater than 0, okay. Yeah. No. Which way? Look at that! There is no escape from the Temple of Thoth. We'll see about that. What if I were to just walk? A hidden door slammed shut, except we haven't implemented the hidden door, which is 17A4 and 18F4. So we can just keep walking. Another hidden door slammed shut. Okay. So I think that this maze, the only real trap is the hidden door. And like, there's like hidden doors and there are secret doors, I think. Yeah, a secret panel slides open. Okay. These are the two things that are inside this maze. The other mazes have like different hotspots, but I think we can sort out what we need with just these three stubs. So let's see if we can get that sorted out before the end of the stream.
Prompt service is required.
Oh, thank you very much for the follow. I am observable. Good to have you around. Sorry that this is mostly just me typing. At this point, sub 136.1784 broke out of switch statement. Sub 136 2D4C. I think these are all ones that I've added already, so just because they're wall drawing commands. Okay, and then after that, it's return. Okay, that was function 1. We need 1756, which I guess removes lines. Oh, I'm Observable says, thanks, enjoy watching the process. I'm glad that someone's getting a kick out of this. Actually, this is honestly like, this is quite relaxing. This is literally just defocusing your eyes, looking at a bunch of assembly, and then pulling C++ out the other end with like a little bit of troubleshooting when I make a mistake. I mean, compared to Director, where it's basically just kind of a fractal of things that you have to kind of investigate in order to troubleshoot a single thing, and then God help you if it requires refactoring, and then it's like, oh my god, I have to change all this code just to fix like one little piece of... Anyway, this is better. This is what I'm aiming towards. This is a lot better. A lot more relaxing than fixing Macromedia Director. exactly the same commands. Two 4C, 2DD0, 2E52, 2ED6. Great. That just leaves one last stop, and that was 18F4. Oh, good. It's not too complicated. Var 1C2. Oh, Observable says, I remember using Director back in the day. It was using an Amiga toaster in the same job. Yeah, video toaster is pretty cool. But yeah, given that you're probably aware that, I mean, you are probably more than aware that a lot of stuff from about like the early 90s all the way up to the 2000s, games, reference books, museum exhibits, visualizations, whatever, it was all done in Director. And so, yeah, that's why I'm trying to add all of Director to ScumVM, which is kind of an insane task, but we're getting there. Gotten most of the stuff before like 1997 working pretty well. Which is important because, I mean, that stuff is absolutely not going to get... you need either ancient Windows or ancient macOS to run it, so the only chance that this stuff has for being sold again is if it gets emulated in ScumVM. And then when we do that, then it also means we can fix some of the, fix some of the issues, like Director, or old Director especially, is kind of notorious for being very finicky for running under emulation, whether that be because of the videos or because of various, window, like the Director 4 and Director 3 for Windows 3.1, they crash all the time. And they also run far too fast. Like, there's something like just little things like you can set like the smallest kind of frame rate that you can set is 60 frames a second, or the finest frame rate you can set is 60 frames a second, and Director just takes it as a signal to draw as fast as it can. It does not actually cap it at 60 frames a second. So there are plenty of games which are designed for hardware that's in like 1993, 1994, and then as soon as you run it in an emulator that doesn't enforce that constraint, it just runs at like hundreds of frames a second and is unusable. But that's like an example of something we can fix quite easily by enforcing a frame rate cap in ScumVM. Anyway, that was a big old tangent. We should just get this done. 1, 2, it's a basic mid stir. Sub 136.248. Okay, that's something else that we sub. Really, there's even more functions that we got to do. I was hoping we were kind of getting towards the end. Whatever, we'll just do it this way. Okay, let's just add those functions in. Well, crap. Oh, Ryan Observable said, "Oh wow, didn't realize that. Probably a CPU thrash, I imagine. I was just thinking about writing lingo with Director and how accounting for that must be difficult. But yes, I digress. We'll let you focus." Oh yeah, lingo is. I mean, I have a love-hate relationship with lingo. Like honestly, I think compared to pretty much every other, it's amazingly ahead of its time. It's got duck typing. It has a lot of things which make Python quite easy to use, like the natural kind of the way that everything is kind of phrased in quasi English is, it's a quirk, but it's not. It makes sense for the most part. The bit which kind of drives me insane is that there's a lot of undefined behavior, and we have to support all of it. So, and to their credit, over time, like later releases of Director, they did tighten up on what was and wasn't undefined behavior. But like the early versions of Director had insane things would happen if you like added incompatible types together. Like if you added lists and numbers, or if you compared lists and numbers, sometimes it would just compare it to the first element. Other times, and there's like various other things about like what void is equal to. Like there were very clearly wasn't a test case, like test suite or any kind of standard for that coming out. So we just have like an enormous set of manual tests which we've verified against the original, and we have to kind of, I don't know, check against each version to make sure that nothing has changed, or when it has changed that we've got a workaround in place. But yeah, a few kind of very odd things there, but then it's just part of the game, I suppose. That's what I was doing. Sub 136. Yeah, we're almost at the end of the stream, but I really want to see what happens. Actually, I'm keen to see if like this is enough to make the maze completable, because I'm pretty sure that these are the archway. At least as far as the archway goes, those are the only two types of interaction that are on this maze. Okay. 24A and 2538. Oh, it's like a little animation that plays. 50E. Bar I16 1DF4. Bar I16 1372. Okay, this is apparently the first time we use 1DF4. Yeah, okay. First time 1DF4 is referenced, so presumably the other function that we got to add does it. variable, another variable that I've never seen before. So it's 2480 and 2538. Yeah, greater than 0. Four eight four 2. Oh, 484 plus 2. Plus 4. Times 2. Plus 6. Sub 12850E. Oh, I missed a. So yeah, it's meant to make a little sound. Oh, it's a 0. Okay. 0. Okay. Despair. Okay, let's see if we can escape. Yes! Look! The door slams shut. Isn't that cool? panel slides open. Oh. Okay. Oh, interesting. I thought what was meant to happen... Oh, hello. Okay. So... this shouldn't be happening. It shouldn't be breaking out of the switch statement. And also, when we go past the hidden panel, it should be closing the door again, but it is not doing that. Okay, so if I go back this way... Wait. Oh, there are two switch statements. Yeah, fine. Okay. Yeah, so what's... var I16 1BD6? So it's... Oh, so... Oh, right. Did I copy pasted that bad? Yeah, I think I might have copy pasted that bad. Yeah, A66. Because, yeah, the argument to that switch statement should be 1BD4. Yeah, okay. I copy pasted that bad. Okay, so archway. Yep, the door is now disappearing after being used. This must have been awful to program. I can't even imagine how you would... I guess you would have to like plan it out on like paper first. Oh. Okay. And then... Okay, we need to get into that. So we need to get down here. Oh. Hang on. Ah, crap. Okay, I understand now. No. Okay, we need to. Okay. If you move to the right, then you get sent through the door, which we don't want to do. Oh, but then that just kind of sends us back to here. Here we go. Okay. Well, we made it to the end, but unfortunately we did not have the code which I don't know, the victory condition code seems to be broken, which is unfortunate. But whatever. That's still pretty good result for an evening. And we're going to leave it there because it is quite late. Thanks for tuning in. Let's see who's doing stuff on Twitch.tv. Oh wow, spoiled for choice tonight. Okay. Wow, alright. Oh crap, I've stayed up so late that, you know what, we're gonna raid a good Pete who is currently in the middle of watching Armchair Detectives, because why the hell not? I'll be back on Thursday doing director stuff. Thank you very much for watching. I will see you next time. Goodbye.